In today's lecture, we're going to start Chapter 6, and this chapter covers two related concepts, one of which is schedules of reinforcement, and the other is choice behavior. So today's lecture is mostly going to focus on schedules of reinforcement. We're going to dabble just a little bit in the introduction of choice behavior, but the majority of choice behavior will be covered in the next video. So with that out of the way, let's start by talking about reinforcers, and specifically different kinds of reinforcers. So we've already kind of covered some of this, where we have primary reinforcers and secondary reinforcers. So our primary reinforcers are our USs, or unconditioned stimuli, things that are naturally reinforcing, things like getting food, and I apologize for all the cookie cravings you might have now. For secondary reinforcers, these are things that are our conditioned stimuli, things that are reinforcing simply because they have been associated with primary reinforcers. These are sort of more abstract things like tokens or money or even grades, things that we've associated with primary reinforcers, the things that you can get with money, the things you can trade tokens in for, or grades just being associated with having done a good job, or possibly the praise that comes with it. A little bit more complicated there. Our reinforcers can also be intrinsic or extrinsic. Intrinsic meaning that they are internally driven. So an intrinsic reinforcer is something that we want to do because we find it rewarding to ourselves. So people who read because they enjoy it. People who choose to run every day because they enjoy how it feels. In contrast, our extrinsic reinforcers are external reinforcers. You gain some kind of award or avoid some kind of aversive stimulus by doing the behavior. So maybe you work because you want money or study because you want a good grade. So our intrinsic reinforcers are internal and our extrinsic reinforcers are external. Now, I did mention in the last chapter that we focus mainly on reinforcement and that we'll talk about things like punishment later on. In fact, we'll spend a whole chapter talking specifically about punishment and how that works, but we're focusing on reinforcement and mostly about reinforcers. So pretty much exclusively positive reinforcement, simply because that is the easiest way to talk about these concepts at first. We'll expand a little bit later on. I did mention previously that we can have things like negative reinforcement, where if you have aversives, so things that are not reinforcers, that can end up reinforcing behavior, so escape behaviors. Primary example of that would be a Morris water maze, where mice and rats can swim, but they really dislike it. So in a Morris water maze, there's a platform that they can locate, and as soon as they find it, they can get up out of the liquid. So they're going to be motivated to get out of the liquid because they don't like it. So over time, they learn to locate that platform much, much faster. So their behavior changes based on this desire to escape from an aversive situation. So it's not that these situations are only possible to happen with reinforcement, it's just that it's easier to talk about them in terms of reinforcement, so we're sticking with reinforcement, and specifically positive reinforcement, for most of this chapter, and then we'll eventually start introducing other kinds of behavior motivators. But with that out of the way, let's actually talk about different schedules of reinforcement. Now, so far in this course, we've talked kind of under the assumption that every time you do a particular behavior, you're going to receive a reinforcer. So this idea that behavior is going to be reinforced every single time it occurs. Now, that's not always the case in the real world. Instrumental responses rarely get reinforced every single time they happen outside of the lab. So now, if we're going to talk about more realistic scenarios or even just different scenarios, we're going to talk about different types of schedules of reinforcement. So the one that we've been using so far, where every single behavior is reinforced every single time, that's called continuous reinforcement, sometimes shortened to CRF. And the name kind of makes sense, where you are continually being reinforced for performing that particular behavior. The other alternative, the one that we're going to be talking about now, is intermittent reinforcement. This is when not every single action is going to be reinforced every single time. We're introducing some kind of schedule. We can call it a program or a rule, something that's going to determine the rate at which a certain instrumental response is going to be followed by the delivery of a reinforcer. So when we're setting up a schedule of reinforcement, we're deciding how often a certain kind of behavior is being reinforced. So what's the difference besides the continuously being reinforced versus intermittently reinforced of these two schedules? The main benefit to a continuous reinforcement schedule is that it's very easy to learn an association between performing a certain behavior and obtaining that reinforcement. So if you're trying to teach someone to do something and you want to use reinforcement to get them to do it, then you're probably going to want to start out with continuous reinforcement. You get more presentations of that reinforcer following the behavior more closely together, so the rate of learning is a lot faster. The downside is that when you have continuous reinforcement, if you suddenly stop reinforcing that behavior, then you go into extinction pretty much immediately. As soon as the animal stops getting their reward, or reinforcer, then they're going to enter into extinction right away because they're used to getting that reinforcer every single time. In contrast, with our intermittent schedules, you are more resistant to extinction because you're used to not getting reinforcement every single time. So even if we stop reinforcing a particular behavior, we've introduced sort of some uncertainty where the animal thinks that they should be getting a reinforcer, but in the past they haven't always gotten one, so maybe they're just maybe they just haven't been keeping track. Maybe they aren't quite ready, or maybe they aren't keeping track of the situation. Maybe they don't know what's going on specifically. I don't know. That's a little bit thought intensive, but we're saying that we're introducing some uncertainty here so that instead of immediately entering into extinction, they'll persist with doing that behavior in case they can still get reinforced in the future. Another benefit of intermittent schedules is that you need fewer reinforcers because you're reinforcing less often. If we have a continuous reinforcement schedule, if the rat presses the lever 10 times, then they get 10 pieces of food. But if we have an intermittent schedule, then maybe that rat pressing the lever 10 times only gets 1 piece of food. Depends on our schedule of reinforcement. But we need less of it, and therefore the rat is less likely to be satiated, and it's all sorts of different things like that. Okay, so before I go into the different kinds of intermittent schedules of reinforcement, let's actually talk very briefly about how these different types of schedules are usually shown. So specifically, what are we going to be seeing and how can we interpret the visuals that we're going to get when we talk about these different schedules? Now, when looking at these reinforcement schedules and amount of reinforcement that an organism has been given, we almost always see them presented with a cumulative record. And these are kind of a carryover from when these kinds of experiments were originally performed back in the 50s, where responses would be recorded on a moving piece of paper. So let's explain the situation here. We have a roll of paper that is wound up on this machine here. And this roll of paper will unroll at a predictable rate. So maybe it's a centimeter every minute, or maybe it's faster than that, or maybe it's slower than that. I guess it depends on how much responding your organism tends to do and what you set it to do. And then what you have is a pen that will sit on the paper. And this would be connected to an operant box. So one of the enclosures that we've seen in the past, and we've talked about, say, a rat pressing a lever or a pigeon pecking a key or something like that. And so every time that lever is pressed, that key is pecked, it would send a signal to this device here. So the paper is unrolling continually, and then as a response is made, this pen device, this drawing utensil, will hop up one increment. And so let's start at the beginning here. So at the very beginning, between A and B, we'd have no response. Maybe the rat's just hanging out in the box doing nothing. But after this amount of time has passed, they make their first response. So we see a hop upward. That vertical jump would come from the pen moving up because the lever was pressed once. Then more time passes, and then the rat presses the lever again. So a second jump, and then a third jump, and a fourth jump. And so we can see a rate of responding based on the slope of this line. So between B and C, they're responding maybe once every 5 seconds. But then over here, our responding is much, much quicker. So the steps are smaller, which means that the button is being pressed or the lever is being pushed or whatever is happening more and more close together. So between C and D, we have a faster rate of responding. So maybe instead of 5 seconds, it's every 2 seconds. And we can calculate that out because we know that the paper is unrolling at a particular rate. So the distance between these 2 points would tell us how far apart in time those points occur. And then we get to the top here and we have another period where there's no responding for a little while. And then we had more responding here, and then there's sort of a weird carryover. This you don't really see on modern graphs because it's kind of ugly and hard to look at. But this would just mean that the pen has hit the edge of the paper and the machine has reset down to its baseline. So what we would do is know that we had sort of 1, 2, 3, 4, 5 responses, and then it moves back over here, and then we'd see our 6th response, 7th, 8th, 9th, and 10th. So it just sort of scoots down, kind of like a typewriter where it would be pushed back to the beginning of the row, the next one down, just so that we can keep tracking this responding even though it would have run off the page. But our important thing to note here is that this is one response, this is one response, this is one response. So what we're seeing here is a cumulative or an accumulating record of all of the responses that have been made over the course of whatever trial or whatever session we're running. So we can actually count each of these little peaks here to tell how many responses have been made, and we can work out when they've been made or how many responses over a certain known amount of time or whatever. So this is a visual representation of when and how frequently our participant or our organism is responding during a given session. So our slope is the rate of responding, and we can identify each individual response because of the properties of this setup here. Hopefully I didn't overcomplicate that too much. Nowadays, we don't still use this same setup. We don't still use a roll of paper that continually unrolls. We now have computer programs that track each input from an operand box. But a lot of our data is still presented as a cumulative record simply because that's what the field is used to seeing. So as we walk through each of our different schedules of reinforcement, we'll actually show data as a cumulative record, where we can see each subsequent response getting added to the total as we count up. And that's just what we tend to see in this area, just so that you know what you're looking at, and a little bit of history as to why. Now, in previous courses, you will absolutely have been introduced to our basic schedules of reinforcement, our ratio and interval schedules, whether they are fixed or variable. Those 4 standard options, you've probably seen them in 104 and then again in 282, and now you're going to see them again. So a little bit of review yet again, but that's okay. The thing about these upcoming schedules of reinforcement is that they each vary along a single factor. So maybe we're looking at the number of responses that are given before reinforcement arrives, or how much time has passed before that behavior can be reinforced. Those are the two main ones that we look at. For our ratio schedules, we care about the number of responses that have been made. So in a ratio schedule, the reinforcer is given after the animal makes the required number of responses. So maybe you have to press that lever 10 times in order to get a piece of food. There is a special thing to note here that if the required number of responses is 1, then it's going to be continuous reinforcement. So continuous reinforcement, the one we've been talking about all throughout the course so far, is actually technically a ratio schedule. It's just a ratio schedule of 1. So we might see it noted as that CRF, or you might even strangely sometimes see it noted as FR1, just depending on how people want to note it. An example of continuous reinforcement would be that if you put money into a working vending machine, you should always get out the item that you have requested. So if that vending machine is functional, you should put money in and get your candy bar out. Things change up if you get a non-functional vending machine, but we'll talk about other schedules coming up. So of our types of ratio schedules, as I alluded to, we have our fixed ratio schedule, or FR schedules. These involve a fixed ratio between the number of responses that you make and the number of reinforcers that are delivered. So for an FR10, a fixed ratio of 10, there needs to be 10 responses made in order to receive a single 10 responses made to receive a single reinforcer. Some examples that you might see in the real world would be for every 50 newspapers you hand out, you get $5. Or if individuals work in a garment factory, maybe they're paid per number of garments that they make. A weird example that the textbook uses is the idea of dialing a phone number. Every phone number has a certain length, and you have to press all of the numbers in that phone number in order for it to dial. So it has to be 7, or if you're outside of your local area code, then 10 digits before you can actually call someone. So all of those are fixed ratios. And we have some key identifiers that are very closely related to this fixed ratio setup. I'm actually going to flip to the next slide so that we can actually see them on one of our graphs here. So this is that cumulative record that I was talking about, where we would be seeing rates of responding. And on these ones here, a little tick mark indicates each time that reinforcement has been delivered. So you might notice that each time reinforcement is delivered, we see this plateau, where if you think back to our cumulative record machine here, that those flat points are pieces where there is no responding. So after reinforcement has been delivered, there's a period where no responding is made. We can call this the post-reinforcement pause. So just after a participant has received reinforcement, they tend to procrastinate or delay starting to respond again. However, once they do start responding, we tend to see a pretty reliable, pretty continuous rate of responding. So this would be called a ratio run, which is a high and steady rate of responding, where once they start responding, they're usually going to continue responding at a fairly fixed rate until the next reinforcer is delivered. Then we see another of our post-reinforcement pauses. It has also occurred to me that we don't have our axes labeled here, so just a quick pointing out. As usual, this axis is time. So this is the passage of time as we go this way, and then this axis would just be our cumulative number of responses. We don't have specific units because these are ideal examples of our different schedules of reinforcement, so these axes don't really matter all that much right now. This is just sort of the standard pattern that we would see if we were seeing any kind of fixed ratio schedule of reinforcement here. There's one other thing that we sometimes see associated with a fixed ratio schedule of reinforcement, and this is called ratio strain. And this is, you don't see it here because this is a fixed ratio with no change being made. But we can sometimes observe ratio strain if there is a change up in our requirements. So if we started with an FR10 and then we switched to an FR20, where at the beginning the rat had to press the lever 10 times to receive reinforcement, but we switch it up so that afterwards they have to press that lever 20 times to receive reinforcement, then we might expect to see ratio strain, which is a disruption of responding. Basically, they would periodically pause during this responding. So instead of just a continuous straight line of the same amount of responding here, we might see pauses. So little periods of inactivity, and those just occur because we have basically moved the goalpost. We've changed our ratios, and so there tend to be little pauses there because we've changed up our pattern of reinforcement. So we don't see that here, but that is something that can occur if you move the ratio, if you change the ratio during a session. All right, our next type of ratio schedule is a variable ratio schedule, or VR schedule. And this is where a different number of responses are required for the delivery of each reinforcer. So instead of our fixed ratio, the previous one, where there's a set number of responses that need to be made in order to get reinforcement, with a variable ratio, the number of responses that need to be made is variable. It's going to be changing and flexible. So what we tend to report is a VR of the average number of responses that's needed to receive reinforcement. So a VR of 5 says that every 5 or so responses you will receive reinforcement. And that little bit of variability in there, that or so, or 5 on average, tells us that it's a variable ratio. So usually if we were describing a scenario and you had to identify that it was a variable ratio schedule, they would say that maybe every 10 times plus or minus a certain number, there would be reinforcement. That tells us that there's some variability and therefore it is a variable ratio schedule. So an example of this would be gambling. So you never know when you're going to hit the jackpot, but maybe there's a built-in ratio or average number of pulls on the slot machine where you would win whatever's on the screen. So there's sort of a background average present, but you don't know exactly when that reinforcer will arrive. And our rate of responding will vary based on the average VR. So with our example here of VR5, so on average every 5 lever presses is going to get you reinforcement. That's a low enough ratio that there would probably be fairly continuous responding. The minimum number of responses that are required to see reinforcement is also going to play a role. So with our VR5 example, if the minimum is 1, then you would see pretty much continuous lever pressing because it doesn't take a lot of presses to get a reinforcer, and it can happen as soon as the very next trial after you've received reinforcement, so there tends to be lots and lots of lever pressing. If, however, that average VR was higher, or if our minimum number was a lot higher, we might see slower rates of responding. So our variable ratio ones tend to, again, be a little bit variable in what the data looks like. But the overall pattern that we tend to see would be something like this. So instead of these predictable fixed ratio graphs where we have our plateaus and we have our continuous ratio runs and we can see sort of a predictable pattern, our variable ratio schedules of reinforcement tend to have very little pattern to them. We see almost continuous responding. And again, we have ticks here to indicate when reinforcement is delivered. And this is entirely dependent on how quickly the organism presses that lever or pushes the button or does whatever the behavior is. So you can occasionally see post-reinforcement pauses, especially if you have very high ratios or very large minimum numbers of responses required, but they tend to be a lot less likely and a lot less pronounced than you'll see in the fixed ratio. Overall, with anything that is variable, you tend to see a fairly steady rate of responding. Okay, so those are our ratio schedules. Now let's talk about the second type of schedule, and these are our interval schedules. So now instead of caring about how many responses are given, we're now going to focus on paying attention to how much time has passed, an interval of time. So for both of our types of interval schedules, our responses are only going to be reinforced if the response occurs after a certain time interval. Now, it's really important to note here that while we care about the time interval, so we can have an interval schedule where after 10 seconds, you can receive reinforcement. There still needs to be a response made once that reinforcement becomes available. So with our interval schedules, we set a time interval, and after that amount of time has passed, the reinforcement becomes available. So that means that if the rat presses the lever after this time interval has passed, then they will be reinforced. However, if they don't respond, if they don't press that lever, the food reward is not automatically delivered. There still needs to be some kind of response. It's just that we're waiting for the first response after a particular amount of time has passed. I find that sometimes students get caught up on the fact that this is a time interval and don't realize that there still needs to be a response made. So just something important to make note of. We do still care that there is a response made. We just care a little bit more about the time interval in terms of how that influences the rate of responding and stuff like that. So as you might anticipate, we can start talking about fixed interval schedules, or FI schedules. And this is where a response is reinforced only if it occurs after a set amount of time. So responses during this interval, when they're not being reinforced, don't really matter. They can respond a lot or a little bit. What actually matters is the amount of time that passes, and they won't receive reinforcement until that time window has passed. An example of this is when you're doing your laundry. No matter how many times you open the door of the washing machine to check if your clothes are done, it's not going to be done until the time is up on the whole cycle. The same with studying. It doesn't matter if you study every night or only every other night or maybe only right before a test. You won't see the reward for studying, that reinforcer of getting your grade back at the end, until a test actually occurs. And so as a result, we tend to see an increase in responding for fixed interval situations towards the end of that time interval. So with our studying example, people tend to study more and more frequently as a test gets closer and closer. People who are impatient for their laundry to be done might walk over to the laundry room more and more often as the time is almost up. So those sort of increase in behavior towards the end of a time interval shows up as a fixed interval scallop, which if we hop to our next slide here, we can see as sort of this increase in behavior towards our next period of reinforcement. So again, the tick marks are when you get reinforced. So there's sort of a trailing off of behavior, same as before, where immediately after getting reinforcement, you know that you're not getting reinforced for a while, so you kind of stop responding, and then you slowly start responding more and more and more until you're responding fairly often and fairly quickly right before the next reinforcement period. Now, it is probably important to note that this scalloped effect that we observe here only really appears if the individual has some ability to tell time. So, if they have some concept of how much time has passed and when they should be receiving their next reinforcement, that's when we see that uptick in responding. Otherwise, we'd see fairly consistent responding all the time. But we'll talk more about timing in chapter 12. So that's its own can of worms to open up. So for the most part, we'll see something kind of like this, maybe even more rounded out. It doesn't have to be quite so pointy there. It just sort of depends on what situation we're looking at, but we do see that increased in responding right before reinforcement. And the last of our 4 basic interval schedules is the variable interval schedule, or VI schedule. So this is when responses are reinforced if they occur after a variable interval of time. So again, after a certain amount of time has passed, but we're taking the average amount of time, and it might be longer, it might be shorter. So whereas our fixed interval might say every 10 seconds, our variable interval would be something like every 10 seconds plus or minus 3 seconds. Or every 10 seconds on average, but we might see reinforcement as soon as after 7 seconds or as long as after 13 seconds. So again, as soon as we introduce that little bit of wiggle room, as soon as we introduce that variability, then we're talking about some kind of variable schedule. So an example of this is waiting for the bus. Maybe the bus is supposed to come every 15 minutes, but if you've ever waited for a bus, it's very rarely exactly on time. So sometimes the bus comes sooner, maybe it's going to be there in 10 minutes. Or maybe it's going to take longer and it won't be there until 20 minutes. So there's some variability in that schedule of reinforcement. And again, whenever we introduce variability, we tend to see a fairly consistent rate of responding. So we don't see as much of a drop-off after reinforcement has occurred. And that's just because there's variability in when you get reinforced. Some of these reinforcement ticks are very, very close together, meaning that they were reinforced fairly soon after a previously reinforced press. So if there's this variability here, you may as well keep responding at a fairly consistent rate because you could be reinforced at any point. Now, our interval schedules of reinforcement come with one extra sort of special concept that we want to consider. And this is the idea of a limited hold. So sometimes the animal isn't responding very consistently. So maybe you have, after 5 minutes, the first response that they give after that 5-minute interval has passed would be reinforced. Well, what if 5 minutes comes and goes and the organism hasn't responded yet? How long do you wait? How long do you hold on to that potential reinforcement before they expire? In some experiments, there is no expiry on that. That potential reinforcement may sit there for as long as it takes until they next respond. So it might be 10 minutes later, it might be 20 minutes later. The first response that they make after that interval has passed, they're still going to get that reinforcement. But some experiments will have what's called a limited hold, which is basically a set amount of time after which that reinforcement is no longer available. To think about it, you might think of a limited hold as a restaurant that opens at 8 a.m., but they only serve breakfast until 11 a.m. If you don't come in and try and get food until 11:30, then you've missed out on your opportunity to get breakfast. So if too much time has passed, in a situation where there is a limited hold on that schedule of reinforcement, they may not be able to get reinforcement after that option for reinforcement has expired. So if ever there's a situation where limited hold applies, the experiment will usually specify that for us and point it out. Otherwise, we just assume that it's infinite and the next response after that time period has passed will receive reinforcement. I just want to draw your attention to the fact that that option can exist. Now, looking at our graph of these different types of reinforcement schedules, or the rate of responding that we observe for each of these reinforcement schedules, we obviously see quite a few similarities. Our fixed ratio and fixed interval both show post-reinforcement pauses. They show that little plateau after reinforcement has been given. And our variable ratio and variable interval both show fairly continuous rates of responding. So that tells us that there are some similarities between these types of schedules of reinforcement. But of course, researchers would want to try and quantify these similarities and then also look for differences between fixed and variable schedules of reinforcement and interval and ratio schedules of reinforcement. So let's look at an experiment that actually tried to pick apart some of the specifics of these different kinds of schedules. All right, so this is a study by Reynolds back in 1975, and they wanted to compare ratio and interval schedules. So in both cases, they wanted to look at variable responding. So they have a variable ratio compared to a variable interval. Just as a reminder, our variable ratio and our variable interval. So there isn't a set amount. This one is a variable amount of responding, and this one is a variable amount of time. And they set it up so that the opportunities for reinforcement were identical for each bird. They wanted to control for as many different factors as they could, so the opportunity to get reinforcement was kept the same for each bird. And they did this by having our variable ratio bird sort of drive the whole scenario. So the variable ratio bird would be something like every 100 responses plus or minus 100. So lots of variation in there. And the variable interval bird would be eligible to receive a reinforcer whenever our variable ratio bird was within one response of its reward. So if we look at over here, so our variable ratio bird is the one that is driving all of the responding here. So if our bird is at this point right before they get their reinforcer, that would trigger a chance for our variable interval bird to receive the reinforcer. So our variable ratio bird would peck, 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 up until they're right about to get their reinforcer, and then that would signal for the box that the variable interval bird is in, that the next peck that they make, they would receive reinforcement as well. So our time intervals are actually controlled by the performance of our variable ratio bird in this experiment. And this setup was used to try and keep that rate of reinforcement as consistent as possible between those two different setups, where one is determined by time and the other is determined by amount of pecks. But they'd be able to receive reinforcement around the same time. So what did they end up seeing? So this is kind of a wonky looking graph here, but along the bottom we have indications of when reinforcement was given relative to time. So this is effectively our x-axis here, even though it's not really labeled as such. And then here we would have our y-axis, and that's labeled as 100 responses in this amount of rise. And so we can see that these two tick marks that occurred after, looks like just under a minute, we see two equivalent reinforcers here for our variable interval bird. And then up here we see two tick marks again for reinforcement for our variable rate reinforced bird. So this is just showing us what we explained on the previous slide, where when the variable ratio bird was receiving reinforcement or about to receive reinforcement, our variable interval bird also received the opportunity to respond and then get reinforcement as well. So with that equivalent rate of reinforcement, we actually see that our variable ratio schedule produces much higher rates of responding. So this bird is responding much more quickly, and our variable interval bird is responding much less quickly. So here we see 5 responses per second, versus for the variable interval bird, we see a response of about 1 per second. So that variable ratio schedule will produce a much higher rate of responding than a variable interval schedule when everything else is kept consistent. So when we control our rate of reinforcement, we still see a much higher rate of responding for VR schedules than for VI schedules, which is really cool. So as sort of summing up our comparison of schedules, comparing our variable schedules and fixed schedules, we saw from just looking at our graphs of ideal schedule observations, our variable schedules produce much steadier responding rates compared to fixed schedules. Our fixed schedules, whether they're variable or whether they are ratio or interval, tend to show those steps or scallops, whereas the variable schedules are much flatter, more consistent lines. And then from the experiment that we just looked at, ratio schedules produce higher rates of responding than interval schedules. So that's our comparison between those 4 different types. All right, so that brings us to the end of our schedules of reinforcement portion of the chapter. The next section is all about choice, and I'm going to touch just very, very briefly on choice, just to kind of give us more time in the next lecture. So we're going to switch gears just a little bit and start talking about choice. So again, so far, up until this point, we have talked about only having one response option, pressing the lever. So we're looking at rates of response when there is one action that can be performed. Now we're going to start looking at choice, some kind of cognitive deliberation where you can choose which action to take. Outside of the lab and outside of what we're going to mostly be looking at for this course, there are so many possible choices. And even the situation that we've been presented so far, that idea of pressing a lever or picking a key, that is technically a choice, even though it's only shown as a single behavior, because there's always the choice to do something else, not press the lever, to drink from the water bottle, to go sit in the corner, whatever. There are these options that are available. So if we have this consideration of freedom of choice, we can get into this unpredictable area where there are so many possibilities that it's almost impossible to control all of those other options. So what we tend to look at in terms of research on choice behavior is that we try and look at the difference in responding to 2 concurrent payoff schedules. So you're given the option of choose A or choose B, and we look at the difference in responding of you choosing A versus you choosing B. So by restricting our scope of focus, we can try and understand the choices that are being made. And we tend to try and understand our choices in terms of consequences in order to predict which choice we'll make in the future. So we can look at the consequence of choosing A versus choosing B, and we can predict how likely an individual is to choose A in the future or how likely they are to choose B in the future. So it's usually a probabilistic prediction for future behavior. Now, the standard method of testing this is very similar, again, to what we've been looking at so far. So you can look at a Skinner box or an operant box, and there are usually 2 options available. So here we have a pigeon in an operant box with 2 possible keys, key A and key B. And each key would be associated with a different schedule of reinforcement. So here, key A is associated with schedule A, which is a variable interval schedule of reinforcement where every 60 seconds or so, pecking that key will get them food. We can also have schedule B associated with key B, which is a fixed ratio of every 10 pecks they would receive reinforcement. And in terms of choice, we would care how likely are they to choose A or B. And we can present this a couple of different ways. We can look at relative rate of responding. So their rate of responding to the left key or key A compared to their overall rate of responding. So this is set up here. So BL is the rate of responding to the left, BR is the rate of responding to the right. So this is looking at how often they respond to the left key versus how much responding they do in total. So this way we can kind of see how much responding to one versus how much responding overall that we're seeing. And you can set this up to look at the rate of responding relative to the left or the right. It doesn't really matter, especially where it's a dichotomous choice. So you can kind of calculate the opposite fairly easily if you had to. But that's our relative rate of responding. You might also see this talked about as relative rate of behavior. We can also look at relative rate of reinforcement. So instead of looking at the number of key pecks or lever presses, we would instead look at how often reinforcement is delivered for having done that lever press on the left or that key peck on the left. So this is the rate of reinforcement for the left side divided by the overall total reinforcement, which is the reinforcement for the left and reinforcement for the right combined. So very, very similar to our rate of responding, but this time it's just looking at rate of reinforcement instead. Now those two equations, our responding and reinforcement, sets us up to start talking about matching and laws of matching in the next video. But I find that that concept will drag on quite a while and I don't want to go all the way into that quite yet. So we're going to cut the video here and we'll talk about matching in the next video on Thursday.